Omar, don't forget to record. Nah.
Yeah, I'm going to record this.
Thank
So
you.
for the first test paper, so if you look here, we have some short question. And the first question is, if E is a vector that is this way, and if we do some rule operation, and it becomes this vector, so you can see that the changes are here, right? So we have to take some corresponding identity matrix for this particular matrix. Like this is a 3 by 3 matrix, right? So we have to take a 3 by 3 identity matrix, and then you see here we have multiplied 7 with the first row. So we have to take we have to also multiply 7. You have to multiply 7 with a corresponding 3 by 3 identity matrix. So it will look like this way: 7 into on 0 0 on 0 1 0, and then 0 0 1. Okay, so if you multiply this way, so it will be just multiplied with the first row. So you will get 7 0 0, and then 0 1 0, and then 0 0 1. Okay, so this will be the answer for the first question: 7 0 0 0 1 0 0 0 1. So you see, we just have a look like where the changes has taken, and then we multiply that number with a corresponding identity matrix. Okay, so this way we find the solution. And for the second question here, A is an n by n matrix, then K of A is equal to what? So if you look at my short notes, so I have written here. So you see here, 11, number 11. So we have a formula: determinant of k multiply a, it will be k to the power n, then determinant of a. So this formula is similar to this question. You see here, if A is an n by n matrix, then determinant of k multiply a, it will be k to the power n multiply determinant of a. So this is just a formula. Okay, and then the third question. So the third question here is, if determinant of A is equal to, then determinant of B is equal 8. So what will be determinant of A into B inverse? So A into B inverse means it means determinant of A then multiplied on by determinant of B. Okay, on by determinant of B. So if you just plug in the value, so the determinant of A is 2. So 2 into on by determinant of B is 8, right? So on by 8. So the ultimate the answer is on by 4. Okay. So you can see here the answer is on by 4, right? So for the third question, for the fourth question here, the matrix A is 3 5 2 3. Then A inverse equal to hot. So the formula is okay. So formula is here. Let me show you. Formula for inverse, it is an inverse matrix, right? So formula for inverse, so formula for inverse matrix is here: on by okay. So you see, this is a 2 by 2 matrix, right? So for 2 by 2 matrix, for a 2 by 2 matrix, formula for inverse is here. Okay, here it will be on by determinant of A, and then we exchange this first corner. Okay, you see here, we exchange this first corner, and then we multiply a minus with the second corner. Okay, so you see here, I exchange the first corner, and then I multiply minus with the second corner. So now if I just plug in the values, it will be, so you can easily see here. So we are exchanging this first corner, so we get oh, Laushi did mistake here. The first one is correct. Okay, so no, Laushi didn't do any mistake. So it is just a calculation, okay? So if you see that our formula was on by determinant of A, right? So determinant of A will be, if you just have a look, like, let me calculate here. So we multiply the first corner. So to find the determinant, we multiply the first corner, and then minus, we multiply the second corner. So, okay. So the first corner here is 3 multiplied 3, that is going to be 9, and then minus 5 multiplied 2, that is going to be 10. So 9 minus 10, it will be minus 1, right? So that's why I have written here minus 1. Okay, that's why Lausi has written here minus 1. And then this is the, I mean, if you just follow this step, so we exchange the corner, and then we multiply minus with the second corner. So, okay. So look here, we exchange the corner, and then we multiply a minus here, right? So if you exchange the corner, so it will be also 3 by 3, because it will be also 3 and 3, and then we multiply a minus here. Okay, you see here we have multiplied a minus. So then we now if we just calculate this part, so on divided by minus 1, it will be minus 1, right? It will be minus 1, and then minus 1 multiplied this matrix, it will be just minus 3 and 5 and 2 and minus 3. Okay, you just multiply minus 1 with all these entries. So 1 into 3. So if you just see here, minus 1 multiply 3, it will be minus 3, and then minus 1 multiply minus 5, it will be 5, and then minus 1 multiply 2 is minus 1 multiply minus 2 is 2, and then minus 1 multiply 3 is minus 3. Okay, so I think you can understand this part. And then let's go to the next question. So here is if A is equal 1 2 3 6 5 6 and 2 1 5, then what is the trace for A? So trace, to find the trace, you just need to add this. You just need to add the entries of main diagonal. Okay, so 1 plus 5 plus 5, so it will be 11. So guys, can you understand?
Yes, Omar.
Okay, so let's go to part 2. So for part 2, we have also some maybe 5 short question. Yeah, 5 short question. So the first question here is which of the following matrix is in reduced row echelon form? So if you look here, we know that RREF form. So it will the condition is, the first condition is uh, all the pivot point. Okay, all the pivot point, it will be 1. All the pivot point, it needs to be 1. And then the second condition is, if there is and the second condition is all the entries below this pivot point and above this pivot point, it also needs to be 1, right? It needs to be 0. Okay, the first condition, all the pivot point, it will be 1, and then all the entries below this pivot point and above this pivot point, it will be 0. And the third condition is, if we have a row that all the entries that containing 0, so it will stay at the last. Okay, so now let's see the first question here. the first option here. So we have the first, our pivot point is here, the first non-zero entries, right? So it is 1. Okay, but down here we have on, right? So uh, according to RREF, according to the condition, it must be 0, right? So that's why this is not a RREF form. And for the second option, so this the first the pivot point here, so it should be 1, right? Because the first non-zero entry of this first row, this is the pivot point, so it needs to be 1, but here is 2. So this is also not RREF form. And for the third option, we can see this is the first pivot point, and all the entries below this pivot point is 0. But you see here, we have we have a row that all the entries containing 0, but it should stay at the last, right? But here it is not in the last, so we can say that this is also not a RREF form. And then for the fourth option, so we have the first pivot point here, and then all the entries below this pivot point is 0, and all uh, so these two entries, these two row, all the entries they are containing 0, so they are staying at the last. So we can say that this is RREF. Okay. And for the second question, which is the linear equation in x y, which is the linear equation in x, y, and z? So linear equation means that the power of our variable, they must be only 1. Okay, the power of the variable must be 1. So, and there will be no there will be no functional term. Okay, for example, if I write down 2xy, okay, so you see here we have two variable here. If I write down 2xy plus 5 is equal 3 is equal 9, for example. So you see that x and y, they are multiplied, right? They are multiplied here. So this is called a functional term. For example, here is ln y. This is also a functional term. Here is sin y. It is a functional term. Okay. So if we have some kind of functional term like multiplication of two variable, or if we divide two variable, okay, so that will be not linear equation. For linear equation, the power of each variable, they must be 1. So if you look here, the first option here is the power of x is 1, power of y is also 1, and power of z is also 1. So this is a linear equation. But for here, the power is something else, right? If I calculate this, it will be x to the power 1. So that's okay. But if you look here, sin y, so this is a functional term of y, right? It is a sine function of y. So this is not a linear system. And for the third option, here is x squared. So this is definitely not. And for the fourth option, it is ln y, right? So it is also not a linear system. And the third question here, assume that ABC are n by n matrix and k is a scalar, then which of the following equation is true? So k is a scalar, right? Means k is any real number, a real number. So here k is any real number. So which of the following inequalities is true? So the first option here, AB is equal to BA, but okay. So you know that this is a matrix, right? So matrices are related to vectors. So if you multiply, like if you see that AB vector, it will be minus BA vector, right? If you just exchange their position, so it will be this way: AB is equal to minus BA, because this is not just kind of it is not just numbers. Vectors, it also contain direction. So AB cannot be equal to BA. Okay, if AB equal to BA, then it will be this way: AB equal to minus BA. So that's why we can say that this option is not correct. And then the second option here, a square minus b square is equal to a minus b into a plus b. So okay, so you know that this is a formula, right? This is algebraic formula. But for vectors or for matrices, for matrices, um, this formula doesn't apply, because if you multiply them, a into a is a square, and then a into b is a into b is ab, right? And then minus b into a is minus ba, and then minus b into plus b is minus b squared. So you see here, we cannot cancel out ba and ab, right? Because they are vectors, we cannot cancel out them. If they were some just the some kind of real numbers, we could cancel them, but they are vectors, we cannot cancel out ab and ba. So that's why if we cannot cancel out, so our left hand side cannot be equal to right hand side, right? Because you see here, we have a square here and we have b square here, but we cannot cancel out this part. So that's why our left part and right part, they cannot be similar. So I hope guys, you guys can understand that option B, it is not also true. Okay. And the third question here, it is b plus c multiply k. So k is just a scalar, I mean just a number. So we can write down this way, kb plus kc. Okay, because they are just numbers. And then option D, it is AB transpose. So if you look at my short note here, AB transpose. Yeah, so this is AB inverse or AB transpose. Okay, so AB transpose will be B inverse multiply A inverse. Okay, this is the formula. But here it is written this way: A inverse multiply B inverse. So according to the formula, this is not correct. It should be B inverse into A inverse, or B transpose into A transpose. So just number C or the third answer, it is correct. And for the fourth question here, if a matrix A n by n is invertible, then the following statement is a hold. So yeah, so the fourth question here, if A is n by n, this is a square matrix, right? And if it is invertible, that means we can find out A inverse. And the condition for inverse matrix, so okay, and then the following statement, which statement is true? The first option is A multiply x equal to 0. It have infinite many solution. So okay, inverse matrix. A inverse is identity matrix by a matrix. X equal. X equals you have many many solution. জি, একটু ভালো see. Okay, so I'm not sure about the first. I don't know how to explain the first option, but this is not true. Okay, ax equals 0 may have infinite many solution. It is not true. I don't know where is the explanation, but maybe I forgot. Okay. And for B, the reduced row echelon form of A is I to the power n. So if you look here, okay, so if you look here, A inverse multiply A is equal identity matrix, right? So we can say that the reduced to echelon form of a is I to the power n, because okay, there is another formula, like I'm going to show you. You see here. So we know that to find the inverse matrix of n by n size, if we want to find a n by n size inverse matrix, so the formula is like we just write down a corresponding identity matrix on the right side, and then we do the row operation, and then on the and we make this a as an identity matrix, and on the right side on the right side on the right side we will get our inverse matrix, right? So this process we find the inverse matrix. So according to that formula, we can say that the reduced to echelon form. So I mean the identity matrix. The reduced to echelon form of A, it will be an identity matrix. Okay, because this matrix is invertible, and it is a square matrix. So option B is correct. And for C, A is not expressible as a product of elementary matrix. So that is not true, because if we multiply a matrix if we multiply a matrix with with its identity matrix, so we will get that matrix back. Okay, so if we multiply a matrix with the corresponding identity matrix, so we will get that matrix back. I mean, the answer will be the same matrix. So so A can be expressed. A is expressible, okay, as a product of elementary matrix. So elementary matrix means okay. So it is not identity matrix. It will be elementary matrix. So elementary matrix is some kind of matrix. So if we just let's say we have yesterday I tried to solve a elementary matrix. Let me find a elementary matrix. স্কুল বন্ধ হলি তো বাড়ি না থাকলি তো তুমি ওই ইফতারি পরে দেন না পাবলিক স্টাডিও মানে বাড়ি না থাকলি শনিবার এটা দিয়ে হ্যাঁ আজকে বাইরে আমি গেলাম দুটো নিয়ে আসি 150 টাকা 150 টাকা hi Leb, welcome. So I'm going to find a elementary matrix. Okay, on to so elementary matrix means if we can get a identity matrix for if we perform just one row operation, and if we end up with an identity matrix, so so the matrix is called elementary matrix. Okay, so I'm going to find that kind of elementary matrix. Okay, I think we will look like we will have a look at later. Okay, so A is not expressible as a product of elementary matrix. So this statement is not true. Okay. And for the last option here, so determinant of A is equal 0. So you know that if determinant of A is equal 0, so this matrix is not invertible, right? So this is the condition for a inverse matrix. So for inverse matrix, the condition will be, if you look at my short note here. So here is the condition, right?